Going back to the examples in the book, my next example is 4-8. We are rolling a die, so this is my probability experiment. When a single die is rolled, find the probability of getting a 9. So I have roll a die, and I'm looking for the probability of getting a 9. Now, a die has 6 faces, so 1, 2, 3, 4, 5, or 6. So the probability of 9 has to be 0, because it is not possible to get a 9. Now, same experiment. I'm an example 4-9 now. I'm still rolling a die. Now the probability that I'm interested in is getting a number less than 7. So something that's less than 7. Now, again, a die has 6 faces, 1 through 6. So the probability of getting something that's less than 7 is 100%. My next example is 4-11. In a study, it was found that 24% of people who were victims of violent crimes were ages 20 to 24. If a person is selected at random, find the probability that a person is younger than 20 or older than 24. So the probability that they gave me is the probability that the person ages 20 to 24. So this is my probability of picking that person. Now they gave me this as 24%. I'll write this down as 0.24. So the probability that the person is younger than 20 or older than 24 has to be everybody else. So this is my complement. So 1 minus 0.24, I will get my 0.76. This is an appropriate answer. If you want to rewrite this, change this to a percentile. My next example has to do with empirical probability. The example is 4-13. In a sample of 50 people. So when they say a sample of 50 people, right away I can write down this as a small n. 50 people is my sample. I know that 21 had type O blood, 22 had type A blood, 5 had type B blood, and 2 had type AB blood. Set up a frequency distribution and find the following probabilities. So, my first step, I need to set up the frequency distribution. A frequency distribution, it is what it is. We need to write down what we have. So I have my types of blood. So type O. I have type A. I have type B. And I have type AB. And then I have my frequency. The book says 21 had type O blood. So I'll have my 21. My next type is 22. My next one is 5. And the last one had only 2. One of the things that you want to do is you want to total these up, 43 plus 7, 50, to make sure that that does match with the n that is given in the beginning of the problem. What they're asking us to do is find a few probabilities. So this is part A. If a random person is selected, find the probability that a person has a type O blood. So the probability of selecting somebody with an O. So there's 21 people out of 50. Just going to leave this as the answer. Part B. A person has a type A or type B blood. So I need the probability of A or B. This is actually rule number 4 on my probability chart. And I know that there is 22 people of type A and 5 people of type B. So this brings it to 27 out of 50 as the final answer for that problem. Part C, a person has neither type A nor type O. Not A, I'll write this like this, not A or not O. The best way to approach this is to figure out who they're actually talking about. So we don't want an A, we don't want an O, so that leaves the other 7 people. There's no need to involve probability formulas. And my last example is a person does not have a type A blood. So the probability of does not have type AB, sorry. So not AB. This one I actually do want to jump into my probability formulas because I know that there's 2 people that with the type AB. That means that 1 minus that probability will give me the other 48 people. Probably want to simplify this to reduce a fraction, and that should do the trick for this problem.